So we could do game.odds here already, but let's just do it like this. So we take game, and from there, we take the odds property. And so if we did just this, then this would now create one variable called odds with the entire object in there. But that's not what we want. And so we can further destructure this result. And so remember, we used the colon here again. And to me, this is maybe the most confusing part of this structuring. But, well, that's just how it works. All right. And so now basically we are inside of the odds object. And so now we can just take team1, x, and team2 out. So team1, x, and team2. But now remember that instead of x, we actually wanted to call it draw. And so we use again a colon and then give it the variable name that we want. So that's just like we did it before with the restaurant, but of course applied to another context. Draw and team1 or team2, just to make sure. And indeed, these are exactly the three values that we have up there. Next up, number 6. So this is going really well. So let's create our print goals function now. Like this, which remember should take in an arbitrary amount of players. And what we mean by that is this. So let me start by calling the function here to make that more clear. So in the test data, it says to use Davis, Miller, Lewandowski, and Kimmich. So just like this. But then, of course, it's supposed to work just the same with another number of players. For example, just these two. All right. And so the way we specify that here in our code is to use the rest parameters. Remember that? So this will then basically aggregate all the incoming arguments into one array. And now let's start by logging here how many goals were scored. And so that is, of course, the length of the incoming players array. So players.length goals were scored. And so, indeed, this first call here gives us 4 goals were scored because we have 4 arguments, and then 2 goals were scored. All right. And then after these examples, the instruction tells us to use actually these values. So this game.scored array. Okay, now we cannot just do this, right? I mean, we can, but it's not going to give us the result we are expecting. So instead, we get 1 goals were scored. And so that's because we only passed in 1 argument. Let's take a look actually at the players to see what I mean. And so the problem here in this last function call, let's take out these 2. So the problem is that now we get 1 array, and in that array is this array with the 4 elements, right? And so instead, we really need these arguments here one by one. Right? So we need to take the players out of the array. And I hope that you can see where this is leading. And so we use the spread operator to do just that. And now we are correct. Great. Now we were also supposed to print all the players one by one to the console, but I'm not gonna waste time with that now. We already did that so many times before. Finally, let's now print to the console which team is more likely to win based on the odds variables. So basically these variables that we created here before, team1 and team2, which contain these odds. So remember that the team with the lower odd is more likely to win. And so we should now print that to the console without an if statement or the ternary operator. So you can probably guess that we should use a logical operator for that, right? So what we need to test for first is to check if team 1 is less than team 2. And in this condition, team 1 is more likely to win, right? So let's already print that to the console, and then we choose the logical operator, which allows us to reach the goal here. So team 1 is more likely to win. So basically, we want this here to be evaluated when the result of this operation is true. And which is the logical operator that continues operation when the first value is true? Well, it's the AND operator, right? So the OR operator short circuits when the first value is true. And so that's not what we want. So because then right now it would short circuit and this would not be evaluated. But in this case, when this is true, we actually want the evaluation to continue. And therefore, this is the way to go. And so, yeah, team 1 is more likely to win. Now, if the odds were the other way around, let's say here we had 11, then nothing would happen. And so now we also need to do this here another time and do the opposite, basically. So now if team 2 has less than team 1, then team 2 is more likely to win. And so now we get that corresponding result there. Let's put it back. Okay. And challenge completed. So I hope all of this made sense and that it was a great way of reviewing everything that we had done so far. Let's now talk about a new way of looping over arrays, which was introduced in ES6, and that's the for-of loop. And let's say we wanted to loop over our entire menu here. So let's start by creating again the array with the entire menu, and for that we expand restaurant.starter menu and restaurant.main menu. So nothing new at this point. Now you already know how to loop over this array with a regular for loop, right? So you would have to go through all the steps of setting up a counter, a condition, and also update the counter. And that's a lot of work. And so that's why we got the for-of loop now, in which you don't need any of that. It's so much simpler. And this is how it works. We still write for, and then we create a variable here. Let's just call it item for now, and then of menu. And then we can log to the console simply this item. So let's see if that works, and then I'm going to explain why it works and what this loop does. So indeed, we got all our elements here now individually logged to the console. So this for-of loop, which is called for-of because it is for and then item of the menu, right? So this loop will automatically loop over the entire array, and in each iteration, it will give us access to the current array element, which we can specify here. So in this case, it's called the item, but of course we could call it anything that we want. And so if we simply log the current item then to the console, well, then this is here what we get. Simply each element logged one by one. And that's because, again, the item variable is always the current element in each iteration. And also, just like in the if-else statement, we don't need to create a code block when we only have one statement here to execute. Okay, so that's pretty simple, but it's a really nice level of abstraction over the regular for loop. So we can do the same thing with this one, but without having to worry about all the underlying details such as counters and conditions. What's also great about the for-of loop is that we can still use the continue and break keywords. And this is important because in the next section, you will learn other ways of looping arrays, and in those one, you will not be able to continue or to break. So you will need to keep that in mind. But now, what if we also wanted the current index and not just the current element? Well, in the for off loop, it's actually a bit of a pain when we need that index, because originally the for off loop was really just meant to give you the current element. However, you can get both, and you will have to do it like this. So for, and then again, let's just call it item. But now instead of just menu, we now need to call the entries a method on this array. So entries. And then let's take a look at the item. And so, as you see, each of the item is now actually an array with the index and the array element itself. So let's quickly take a look at what this mysterious menu.entries actually is. So menu.entries. And so here we get this weird array iterator. And so that's not really helpful, but we will learn about iterators by the end of the course. But if we want to take a look at this, we need to essentially expand this here using the spread operator and then create a new array based out of that. So again, this is really just to take a look at what menu.entries actually is. And so we see that it is basically an array which in each position contains a new array, which contains the element, so the element, and the index number of that element in the original array. And so that's why we get 0, 1, 2, 3, 4, 5, 6, plus all of the original elements of the menu. And that's also the reason why then we get this output from this loop now. Because here we now basically have that array, and so now each item of that array is, well, this new array. And so now if we wanted to like print a nice menu, then we could take advantage of this data now. So let's now log something nicer here. So a template string. So let's take the first element, which is 0, and then let's actually add 1 to it so that we can start the menu at 1. So here we're basically going to display like a nice menu in a real restaurant. And so there the numbers don't start at 0, right? And now here, then the actual item itself. So that's at position number 1. And so that looks quite nice, doesn't it? So this works great here, but we are actually at this point smarter than doing it like this. And that's because if item is now an array, we can destructure it. We don't have to manually take element 0 and element 1. That is the old school way. So let's now do it in a better way. And so we can actually destructure the item array here right here. All we have to do is to use the destructuring assignment and then create the two variables that we want. So let's call it I and el for element. And so here we can use I and here element. So let's check that. And indeed, it works the same. And so once again, destructuring made our lives a little bit easier here. So it's a really great addition to the JavaScript language here, once again. And the same is of course true for the for off loop itself, which also makes it a lot easier to loop over arrays. So maybe you've been noticing that we have been talking a lot about ES6 features and even newer additions to the language. And so let's continue with that now with yet another enhancement, which is enhanced object literals. And so let's take a closer look at our restaurant object here. So this restaurant object is an object literal. So you can see that because we basically wrote this object literally in our code using this curly braces syntax. So, well, you get the point. So all of this object here has been written using the object literal syntax. Now ES6 introduced 3 ways which make it easier to write object literals like this. And so let's go through them one by one now. First off, let's say that we have an object that is outside of this object. So let's take this one and create a separate object with it. So const opening hours equal. And so now this is its separate variable. Now here we need a semicolon to fix this error there. But now we still want to have the opening hours object inside of the restaurant. So before ES6, we would have to write opening hours. So that's the property name that we want. And then set it equal to opening hours. And so then basically the restaurant object is restored. Let's see that here quickly. So you see that here we still have the opening hours just like before. Now, the problem here is, and it's not really a problem, but it can become annoying, is that this property name is exactly the same as the variable name from which we're getting this new object, right? And so with enhanced object literals, you don't need to write this. So we can just do this. Let me write this here. ES6 enhanced object literals. And so what this will do now is to take this opening hours object and put it into the restaurant object and create a property name with exactly that variable name. So as we will reload now, then you will see that it's still here just like before. And of course we could change this now, but then we would also have to change it here. Otherwise JavaScript will not know what this variable is. And so now, as you can guess, we have a property called hours. All right, so that's a very handy enhancement. And so let's now check out the second one. So the second enhancement to object literals is about writing methods. So in ES6, we no longer have to create a property and then set it to a function expression like we have always been doing, right? So essentially, we create a property just like we do all the other properties, and then we set that to a function expression. But again, now we no longer need to do that. We can write it in an easier way, which is to get rid of this function, even of the semicolon, and then just like this. And so this now works exactly the same as before, but with a slightly easier syntax. And I actually personally really prefer this new syntax. So I'm going to change this entire object to the new way of writing methods. But this actually comes down to personal preference once again. So if you prefer the old way, you can just keep it like that. So maybe you think it's more explicit if you can actually read the function keyword there. But for me, it's enough that we have the parentheses here. So that alone already shows that it has to be a function. And VS Code itself is also helpful as it changes the color of the methods to green. So VS Code is really smart in that regard. And finally, the third enhancement is that we can now actually compute property names instead of having to write them out manually and literally. And compute just means like calculate. And so let's try that here. So let's say that we had an array with all the weekdays. Weekdays. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And now we wanted to take these property names here out of that array. Okay, so instead of having to write them here manually. So we can do that by using, again, the square bracket syntax. And then in here, we can put any expression, basically. So this was Thursday, so let's say weekdays on position number 0, 1, 2, 3. And of course, we could use destructuring here, but yeah, this is just a demonstration anyways. So weekdays 4, and then here weekdays 5. But let me just show you that we could really do anything here. So we could also compute the name in some other way. Let's just say 2 plus 2 or 2 plus 4. So this doesn't make sense, but yeah, I just want to show you that we can do this. Let's take a look at the object now here, opening hours. And so you see that we still get Thursday and Friday, and then here we get day 6. So we computed this property name using a template literal and then also this expression in here. And this is sometimes extremely helpful to be able to do this. So before we could only compute the values. So here, for example, this could be 12 plus 12, right? But we could not compute these property names, but now we can do that as well. Let's learn about an even newer feature of objects and also of arrays, which is called optional chaining. And this one is really amazing. So let's say that we wanted to get the opening hours of our restaurant for Monday. So let's quickly check that. So restaurant.opening hours. And then, since we are checking for Monday, let's try .mon, so which could stand for Monday. Now actually this property doesn't exist. So you see that this is undefined, right? But let's pretend that we do not know whether this restaurant opens on Monday or not. And that could be the case, for example, if this data came from a real web service, so a web API. And in that service, there could be multiple restaurants and not all of them would open on Monday. And so we had no way of knowing if this particular restaurant would open on Monday or not. But now let's go even further, because we actually want to know exactly the hour on which the restaurant opens on Monday. So let's see what we get. And now we do actually get an error, because the result of this was undefined, and then undefined.open is really an error. So that's the error that we get here. So in order to avoid this error, we would first have to check if this here actually exists. So we could do something like this. If this property exists, basically, then do this. Or we could also use a logical operator, as we already learned, but this here is a bit more readable. All right. So if we did the same for, let's say, Friday, then we already know that Friday exists, and so this would then work, and it would be 11. But let's focus here on Monday, which is the day that doesn't exist. And so now at least we get rid of our error here. So it's not a big deal to having to add this logic here, but it does make our code a little bit more unreadable and more messy. However, this is checking just for one property, so just for Monday. But now imagine that opening hours here would also be optional. Or in other words, that maybe the restaurant object can also not have opening hours. So in this case, we would have to check for both, right? So we would have to do if restaurant.opening hours exists, and if restaurant.opening hours.Monday exists, well, only then log the opening hours to the console. And this can get out of hand pretty quickly when we have deeply nested objects with lots of optional properties. And sometimes that happens in the real world. And so therefore, ES 2020 introduced a great solution for this, which is a feature called optional chaining. And with optional chaining, if a certain property does not exist, then undefined is returned immediately. And so that will then avoid that kind of error that we saw earlier. And this is how it works. So let's recreate it now with optional chaining. So now we can say restaurant dot opening hours dot Monday, and now here is the optional chaining operator. So instead of just a dot, we use question mark dot and then open. Okay, so here is how optional chaining works. So only if the property that is before this question mark here, so only if Monday exists, then this open property will be read from there. All right, but if not, then immediately undefined will be returned. And exists here actually means the nullish concept that we already talked before. So a property exists if it's not null and not undefined. Okay, so if it's 0 or the empty string, then it still exists, of course. So if we try this now, then we get undefined. So that's exactly what I was saying. And let's just, again, recreate it here without the optional chaining, just to see the error again. And so here we would indeed get the error. Again, because all of this here is undefined, and then we read open here from undefined, which doesn't work. But here, this next operation of trying to read open only happens if all of this here actually exists. So if it's not null and not undefined. But if it is undefined or null, then the result will be undefined immediately. So let's take this out again. And so that is why we get undefined right now. And of course, we can have multiple optional chainings. So let's basically recreate what we have here. So in this example, so here we are testing for both opening hours and for Monday. So these are essentially the two optional properties that we do not know beforehand if they exist. So Monday is optional, and that's why we have the question mark here basically asking if it exists. And now we can do the same for opening hours. And now if restaurant.opening hours does not even exist, well, then the Monday property will not even be read. And so therefore we don't get that error. All right. And so this makes it really easy to prevent all kinds of bugs that sometimes we might not even expect. All right. So it also takes away all this work of doing this simply by adding this simple question mark in there. But now let's see a little bit more real world example. And for that, let me grab this weekdays array and put it here. Let's just call it days here, so it's not the same variable. And now what I want to do is to loop over this array and then log to the console whether the restaurant is open or closed on each of the days. So that's a good application of optional chaining right there. So let's start just by logging here the day, just so that you can remember how this loop works. And so indeed, now we can do some code with each of these days here. So let's now essentially do the same as we did up here. So restaurant dot opening hours, but now we cannot do this, right? Because this is not an actual property name of the object. And so remember, if we want to use a variable name as the property name, basically, we need to use the brackets notation. So we learned about this way back in the fundamentals section, and so make sure to remember that. Okay, so basically this would be the same in the first day dot Monday and then dot Tuesday and so on and so forth. But the day here is coming dynamically from this array. Okay. But optional chaining, of course, also works with that. And so now we can ask if open exists, basically. And now let's save this to a variable. And then let's log to the console. And this is not yet complete, but for now, let's see what's going to happen. So on day, and then whatever is the current day, we open at, and then here we use the open variable that we just created. Let's get rid of this console.log here. Okay. So we get on Monday, we open at undefined, undefined, undefined. And then indeed on Thursday, Friday, and Saturday, we are open. And so then we get the opening hour that is actually also in the object. Let's just make sure. So this one is open 12, 11, and 0. So essentially it's open 24 hours. It opens at 12 and closes at 24. So at midnight again. All right. So that's working. But now we don't want this undefined here. Okay. And so just like before, let's set a default value. So let's use or. And so as a default, we want to say closed. So we are open at closed. So that doesn't make a lot of sense. So we could create a better sentence there, but let's leave it like this. But maybe you're noticing that now we have a problem, which is that on Saturday it says that we are closed, although actually we open, or the restaurant opens. So here on Saturday, which is this one, indeed, this property exists. So there is a property called Saturday, and so we have a problem here. And the problem is that the restaurant opens at 0. And so here we have the same problem as before, where 0 is a falsy value. And so therefore, it will then trigger this second part of the operator. But we also saw the solution to this, which is to use the nullish coalescing operator. And so that's what we do now. And now we get back to open at 0. Great. So this is an amazing use case of the optional chaining operator and the nullish coalescing operator working together. And in fact, they were introduced into the language at the same time in ES 2020 because they were really designed to work well with each other. So again, both of them rely on this new concept of nullish. And so nullish values are null and undefined. And that's it. And so that's true both for this nullish coalescing operator and also for optional chaining. Okay, great. Now that you understand how it works, let's move to the next topic, which is on methods. So optional chaining does indeed also work for calling methods. So essentially, we can check if a method actually exists before we call it. So restaurant.order, and now we can check if it exists. So we use the question mark dot, and if it does exist, then we can call it. So let's just pass 0 and 1 here. And then we should always use together the nullish coalescing operator. And so method does not exist. So let's run this. But in this case, the method does actually exist. And so here we get the expected result. When we try to call a method that doesn't exist, so let's say order risotto, and so we never wrote a method for that. And so let's see. And yeah, now we get method does not exist. And so just like before, this optional chaining operator will check if order risotto actually exists. And if it doesn't, well, then it will immediately return undefined. And so all of this then returns undefined. And so here in the nullish coalescing operator, we immediately go to that second operand. So that's this one here. And yeah, then that's the result of this whole operation. So of course, if we hadn't this, then we were trying to attempt something that is not a function. So really useful on methods as well. And finally, optional chaining even works on arrays. So basically, we can use it to check if an array is empty. So let's simply create a users array in which we can put a couple of user objects. So name, Jonas, and email hello@jonas.io. And yeah, this is just for demonstration, so let's just put one object here. And now, to get the name of the first element of this array, we can do this. We can write users element number 0, and only if it exists, so optional chaining, only then take its name. Okay? And otherwise, we want to log user array empty. So let's see. And indeed, we get Jonas. And so again, this optional chaining here tests if the value on the left does exist. So users 0. Okay, so if it was empty, so users, so like this, then we get user array empty. And without optional chaining, we would have to write something like this. So if users.length greater or equal 0, then console.log this here. And else console.log user array empty. All right. And so that looks like a lot more work than what we just have up there. So here we don't need to do any check. So that's a lot better. And so now in both cases, we get Jonas. So get used to this optional chaining operator, which almost always we use then together with the nullish coalescing operator, so that we can actually do something in case we don't get a result from the object or from the array that's here on the left-hand side. All right, and with that being said, I see you in the next video. So we learned about the for-off loop to loop over arrays, which remember is an iterable, but we can also loop over objects, which are not iterables, but in an indirect way. Now, we have different options here depending on what exactly we want to loop over. So, do we want to loop over the object's property names, over the values, or both together? And let's start by simply looping over property names. And so, remember, they are also called keys. Now, ultimately, we will still have to use the for-off loop to loop over the array, but again, we're going to do that in an indirect way. So we're not actually looping over the object itself. Instead, we're going to loop over an array. So let me show you how. So I'm going to call this day, and you will see in a moment why. And now off, and then I say Object.keys, and we pass in the opening hours object. And now let's simply, to see what happens here, log the day variable to the console, and then I will explain what happened here. So, indeed, we get Thursday, Friday, and Saturday, which are exactly the three key names of the object. So we can see that here. So indeed, Thursday, Friday, and Saturday. So let's take a closer look at this mysterious Object.keys. And let's do that here before, actually. So let's just say properties equal Object.keys, and then again opening hours. And now I want to take a look at the result here. And so indeed, it is an array with the three property names. Okay, and we can actually also use this to now compute how many properties are in the object. So let's say we wanted to print a string saying how many days the restaurant is open. That would be simple, right? We can just log to the console, we are open on, and then properties dot length. And now we get the number of properties here, of course. And so that's 3 days. Okay. And so this is also the array that we're going to be looping over. So properties. And that's why I called this variable here day, because this array basically contains 3 days. Now let's actually do something cool here and instead store this into a variable. And let's say open, and then str for string, and here a colon, because now using the loop, I will basically keep adding to this string. So open string plus equal, and then the current day. So day, and then a comma. And so here we are then essentially building just this string. So that's similar to something we did already before. And so the end is we are open on 3 days: Thursday, Friday, Saturday. Great. So that's property names. Let's write that here. Okay, but what if we actually wanted the property values themselves? Well, then we would simply use Object.values. So let's also store this here. And of course, then we need to pass in the object itself. So that's again opening hours. Missing the equal sign. And now let's just take a look at the values. And indeed, these are exactly the 3 values that we specified right here. So this value here, right? So open 12, close 22, this one and this one, right? So before we had the keys, now we have the values, and there is no need to now loop over them again, because it's going to work exactly the same as here. Okay? But now, to really simulate to loop over the entire object, we actually need the entries. And so entries is basically names plus values together. And we already saw the entries before. So when we looped over the array, and I think that's going to be somewhere down here. Oh, and actually I already passed it. So indeed, here it is. So here on the array, we called this entries method. And so the entries returned the index number and the element itself. And so we can do something similar on objects, and that will then also return the key and the value. Okay, now it works differently on objects because it's not going to be a method that we call on the object itself. So here we had the menu array, and then we did that menu array dot entries. But now here we do it differently. So we use again object dot entries, and then we pass in once again the opening hours. So this distinction between the array and the object is important as we loop over the entire object. Okay, I actually run into that problem myself at some point. So that's why I'm telling it to you. But anyway, let's store this again into a variable. And so then you have all the 3 versions here nicely organized in your code. And let's take a look here at the entries now. And so as you might have expected, we now get an array. So all of these keys, values, and entries basically transform the object into an array. And then here we have first the key and then the value. All right. And so now we can use this to basically loop over the object. So for, and now let's start by writing the of. I will just call it x for now, and then we will take a look. So x of the entries that we just generated, and then let's just log them to the console. And so let me get rid of this one here. All right, so that's weird. Oh, it's because, of course, I want to log x. Oh, yeah. That's correct. So now we have each key and each value. All right. Now we want to print to the console a string like this. So on the weekday, and so that is the key. And so I'm using these variables here before I actually defined them. So to make it easier to say what we want to define. So for example, on Friday, we open at, and then we're going to have an open variable and close at close. So how will we do this? Well, just like we did with the arrays, we can use this structuring right here. So let's do that. The first one is the key, and remember the second one is the value. So we could do this, but we already know that this here is an object, right? And so therefore we can also immediately destructure that object here. So fair enough, open and close. So the two variable names inside of that object are open and close. And so here we specify exactly these property names, and so they get destructured. And therefore this works. So let's see that again. And so, yeah, so this is here the value basically, all of this, right? And so here we have open and close. And so that's exactly what we defined here as well. And therefore we then end up with the string here, which got all of the data out of the object into this nicely and neat string. All right. So this part here is necessary because the value itself is also an object. But if you had a more simple object with a simple value, then you would of course only do this here as destructuring, just a key and a value. And of course you could then give them other names as you would like. So here we can just call them day. We can use any name that we want. Awesome. So we're doing great progress here. And now it's time to practice that once more. So I see you in the next coding challenge. Let's challenge ourselves with coding challenge number 2. And in this one, we're going to continue with our football betting application. And let me start by saying that this challenge is actually a bit difficult. All right. But that is on purpose. So after all, it's called a challenge. And so you should really challenge yourself with these exercises. Otherwise, it could be called a coding copy and paste, right? So please try your best to solve these. And you can try the problem-solving framework that we talked about earlier. And of course, you can also use Google, MDN, and so on and so forth. Okay? But with that out of the way, let's get into the exercises. And the first one is to loop over the game.scored array and then print each of the players to the console along with the goal number. So this one is not that hard. And so let's just, So the object is down here. So we're going to use the same object, all right? So this is the array that I was talking about. And so here, in this case, we should print Lewandowski goal 1. Then here, goal 2, Gnarby, goal 3, Lewandowski, and goal 4, Hummels. Okay. Then number 2, use a loop to calculate the average odd and log it to the console. And we already studied how to calculate averages, and so you can go check that out if you don't remember. And here you should actually directly use the object itself. So don't destruct the object first into variables and then use that to calculate the average, but instead really calculate the average of the elements in the object. Okay? Then number 3, I want you to print the 3 odds to the console. And do that in a nice formatted way, like you can see it here. Now here, you're not allowed to hard code the names of the teams, all right? So instead, get them directly from the game object itself. Now, of course here, except for draw, because that's nowhere in the game object. So as a hint, I have here that the odds and the game objects have the exact same property names. And so you can use that knowledge maybe to get the name of the teams here. So these are the three exercises for this challenge, but then I also have a bonus. Now let me just tell you that I will not solve this bonus question in this video because it would take me a little bit too long. But I will still put the solution in the final code of this section, so in the GitHub repository, so you can check out the solution there if you attempt to do this bonus. So this one is really hard, and what I want you to do is to create an object called scorers, which will contain the name of the players who scored as properties. And so Gnarby, Hummels, and Lewandowski were the players who scored in this game. And as a value for each of the properties, we want the number of goals. All right. So this means Lewandowski scored 2 goals and the other 2 players scored just 1 goal each. So this is a little bit difficult again, but you can do it. Well, at least with some research and with some reviewing of all the material of the course so far. Anyway, good luck with this challenge. Take your time, and I see you once you're ready. All right. Hopefully you did at least 1 or 2 of these exercises. And so here goes my solution. And keep in mind once more that my solution might be different from yours, but that's totally okay as long as yours produces the same result. So here the goal is to score over the scored array and print all of the players to the console. So const, and let's again fix that later, and then of game dot scored, and now we actually want the entries. All right, and we want the indexes because we also want the number of the goal. Remember? So goal 1, 2, 3, and 4. Okay, and so entries will give us that. And so now we just need to destructure that into the index and then the player. Okay, actually we don't even need the curly braces. Let's just say console.log and then goal, then the index plus 1 so that it starts at goal number 1, and then simply the player. Let's take a look. Oh, and now we have the problem here that I'm accessing game before it is initialized. And so the problem is that the game is down here. So I will have to take this game object now to that other challenge. So let's just cut it from here and put it here. So now it should work. And indeed, we get the 4 goals nicely printed to the console, exactly in the order in which they appear here. All right, next one. And in this one, we have to calculate the average odd. So the average basically of these 3 numbers here. So what we're going to do is to loop over this object here and simply add all of these 3 values together and then finally divide them by the number of elements here. And so that's how you calculate an average. And so we start by creating the average and set it to 0. And so again, we already did that before, I believe. And so now we can loop over the object, such as I explained it to you before. Const odd of, and now what do we actually want? Do we want the keys or the values or both? Well, in this case, we are really just interested in the values, right? And so this Object.values will give us an array essentially containing these 3 values. So we need to say game.odds. Okay, and now in each iteration, we will simply add this odd to the average so that then in the end we can divide it by the length of this Object.values array. So let's do that. plus equal the current odd. And then finally, average divided equal, and so this is a new one, by Object.values game.odds. And then let's log it to the console. So this one here means basically average is equal average divided by this here. And this is actually the same as up here. So let's refactor it into, let's say, simply odds. And then let's use that here. Odds and odds. And we have a problem. So let's do some debugging here. I will start by taking a look at the average after it is computed here in the array. So average. Oh, so here we have a number, which means that something is wrong here in the division, right? And I see it's because we need to write odds.length. Okay, and so then it will be the number 3 in this case. So before I was dividing by the entire array, and that doesn't make any sense. And so now we should see something close to 4 here. Yeah, so 3.7 essentially. And so that's our result. Okay, and you can go over this code here again if you need to understand it even further. But now let's move on here to exercise number 3. And this time the goal is to print basically the content of the object to the console. So we're going to loop over that. And again, I will first say what we need here actually. So we want to print both the team and the odd. So we need the entire object. And so, just as we learned in the previous lecture, we use Object.entries of game.odds. Okay, and so we know that we get an array of arrays, which in each position will have both the team and the odd. All right, so let's say team and odd. All right, and so here it is us who define the variable name because it is now an array. So we don't have to match any property names. And let's start by simply logging both to the console team and odd. Okay, and so indeed, we already have that kind of working. We already have the team here, and we have the 3 odd values. Now what we want to do is to create a string like this. Let's actually copy this so we know what we have to do. And by the way here, notice again what I explained to you in the last lecture, how in the array we use the entries method to get the entries of the array, but in the object we have to use Object.entries and then pass into the function the object that we are interested in. So that's fundamentally different, so keep that in mind. Okay, so here we now want to build a string like that. So odd of victory Bayern Munich, draw or victory Borussia Dortmund. And so here we're going to need some more logic. Let's just put here some dots. And now here the odd. So the odd is the easy part. So we have that one already finished. But now here we need some more complex logic. And actually let's create this part of the string. So like victory Bayern Munich or Borussia Dortmund or draw. Let's create that here in a separate value. So let's call this one team string. And so here what I'm going to use is to use the ternary operator. Okay, so I will say that if the team here is X, like we have it here, then the string should become draw. And so that will then create this here. So team equals X, then the result should be draw. But if not, then we need the team name itself. So how will we get that? And remember, there was a hint about this. So note how the odds and the game objects have the same property names. And indeed, here we have team 1, team 2, and here we have team 1 and team 2 as well. And so here are the team names. And so let's now get these team names using these keys that we already have here. So we want the string victory. And then we go to the game object and team. Let's check. Now I know, of course, we need to put that string here. So team string, and it works. Beautiful. So let's just recap this part here. So here we go into the game, which is the entire game object, and we take the property team. But team is already this property name here, right? So it's team 1 or team 2. And so then we take that to read the property with the same name from the game object. And so therefore we get Bayern Munich and Borussia Dortmund. Okay, great. So this one was a little bit more tough, but we managed to do it in the end. Now again, I will not create the solution for the bonus, but you can always find it in the final code of this section. And with that being said, let's now go back to learning some more JavaScript. In the past, JavaScript has always had very little built-in data structures. So basically, we only had objects and arrays. But in ES6, 2 more data structures were finally introduced, and that are sets and maps. So these are pretty common data structures that already exist in other programming languages, and now they also exist in JavaScript. So in this lecture, let's learn all about sets. And a set is basically just a collection of unique values. So that means that a set can never have any duplicates, and that property makes them useful in certain situations. So let's create a new set here. Let's call it orders set. Okay. So again, to create a new set, we write new set, and then here we need to pass in an iterable. And the most common iterable here is an array. So let's create an array with a couple of strings now. Let's say pasta, pizza, then pizza again, then risotto. Let's put another pasta and another pizza. Okay, so 6 strings, but of course they could be different data types in here. So set can of course hold mixed data types. That's not a problem at all. Now here we clearly see some duplicate strings. So what do you think that this set will look like now that we created it and when we log it to the console? Well, we get a set. Here we can see it has a size of 3. And the only values that are in there are pasta, pizza, and risotto. So that's right, all the duplicates are actually gone. Now also we can see that a set kind of looks similar to an array, right? So there are no key value pairs, it's just a bunch of values grouped together, in this case, into a set. And just like arrays, sets are also iterables, okay? Now, of course, a set is still very different from an array. So first, because its elements are unique, and second, because the order of elements in the set is irrelevant. And we will see why in a second. But anyway, keep in mind that strings are also iterables. So we can do this. So we can pass in a string. And so now we get a set with these 5 elements. So, and that's the 5 components basically of this iterable, which is this string. And of course, the set could also be empty, just like this. All right. And now let's learn how to actually work with sets. So first off, we can get the size of a set. So order set dot size. And so that is 3. And so in this particular example, this might be useful for the chef of our kitchen to know how many different meals are going to be cooked here. Right? So if this array here is an array of all the orders, then the set of these orders are simply the unique different meals that are going to be cooked. And then the size is how many different meals will be cooked. And just note how it is actually called size and not length like it is in arrays. So don't make that confusion. Next, we can check if a certain element is in a set. So order set dot has, and so this is actually a method. And so let's check if pizza is in there, and let's check if bread is in there. So true and false, and that's exactly as we expected. And so comparing again to arrays, this has method is similar to the includes method in arrays, right? Next up, we can also add new elements to a set. So order set dot. So let's say that now someone ordered garlic bread. And let's say that this actually happened twice. So what do you think that the set will look like now? So order set. And so the garlic bread got added, but only, of course, one of them, because again, the set has to be unique. And so the second one was basically ignored. Finally, we can also delete elements. So let's do that before the log. So order set dot delete. So all of these method names are very straightforward, and that's because this is such a modern feature. So the modern stuff really has this more straightforward names and a different way of working with the data structures. So we have risotto here, and so now here we are deleting it, and so indeed it is now gone from the set. So really, really easy. And in arrays, there's actually no method that is this simple. We will see how to delete elements from arrays later, but I can tell you that it's a little bit more complex. Okay, and that's actually it. But now you might ask, how do we actually retrieve values out of a set? Can we maybe use an index like in arrays? So doing something like, maybe like this here. And the answer, as we will see, is no. So this doesn't work. It gives us undefined, no matter what number we put here. All right. And that is because in sets, there are actually no indexes. And in fact, there is no way of getting values out of a set. And if we think about this, then it makes sense. So there's really no need for getting data out of a set. That's because if all values are unique, and if their order does not matter, then there is no point of retrieving values out of a set. All we need to know is whether a certain value is in a set or not, and that's why we have the has method. If your goal is to actually store values in order and then retrieve it, then the best use case is to just use an array. You wouldn't use a set for that. And so again, there's no need for getting values out of a set, because if you need it, then you would just use an array. Finally, there is actually one more method here, but it's not that important. All we can use it for is to basically delete all of the elements of the set. And so we see that now it is empty, right? But let's put that back so that we can work some more with this set. So as I said, in the beginning, sets are also iterables, and therefore we can loop over them. So let's say order from orders set, and not from, it is of, obviously. And then we can just log the order, and indeed, here they are. So looping is possible just like in any other iterable. All right, so now that we know how to work with sets, let's see a big use case for them right now. So in a normal code base, the main use case of sets is actually to remove duplicate values of arrays. So let's just write that here, example. So let's say that we have an array in our restaurant which contains the stuff of our restaurant. Let's say we have one person that is the waiter, one person that is the chef, another person that is a waiter, then we have also a manager, then we have another person that is a chef also, and another waiter. So that's an array of all our stuff in the restaurant. But now let's say that for some reason we are interested in knowing only which different positions there are in our restaurant. Or in other words, we would basically like to have a unique array of this, right? So this array without all the duplicates, that will solve the problem. So let's create a set for that. Easy enough, right? So stuff unique equals new set, and then the iterable that we need to pass in is the stuff, because an array is already an iterable. Now this is not yet the end of the solution, but let's take a look at it for now. And of course, it needs to be stuff unique. And so, yes, so we have a set now with waiter, chef, and manager. So the three unique positions. But now we actually want this to be an array. But the conversion from a set to an array is pretty easy because they are both iterables. So remember from earlier that the spread operator works on all iterables, right? So that includes sets. And so we can now create an array around this basically, and then we can unpack this entire set here using the spread operator, and then these elements will be put into the newly constructed array. Okay? And so indeed, we now end up with a new array. Okay? So the spread operator here works just like on an array. It works really exactly the same. So it takes all the elements out of the iterable and essentially writes them here like comma separated, right? Now, if we only wanted to know how many different positions there are, then the size property is very useful. So all we would have to do, even though this looks a little bit weird, would be to say new set, then with the array, and then dot size. And that's it. And then we wouldn't even need to have to create the array at all. So if we didn't need the unique array. So if all we had was this, and we wanted to know how many unique positions there are, then this here would be the way to go. And the same could even be done with counting how many different letters there are in a string, right? Because an iterable, or actually a string, is also an iterable. So let's see how many different letters there are in my name. And it looks like there are 11. All right. So, as a conclusion to this video, sets are not intended to replace arrays at all. So whenever you need to store values in order, and that might contain duplicates, always just use arrays. That's also true when you need to really manipulate data, because arrays have access to a lot of great array methods that we're going to study a little bit later. Now, sets have this very useful property of being unique. And it's also very easy to interact with sets by using all of their straightforward methods. However, they are not nearly as important as arrays. So keep sets in mind when you need to work with unique values, but besides that, you can just continue using arrays. So we learned about sets. Now it's time to learn about the other new JavaScript data structure, and that is maps. And let me start by telling you that maps are a lot more useful than sets. So what exactly is a map? Well, it's certainly not the same thing that we use in the real life to find our ways around. No, instead, in JavaScript, a map is a data structure that we can use to map values to keys. So just like in objects, data is stored in key-value pairs in maps. Now the big difference between objects and maps is that in maps, the keys can have any type, and this can be huge. So in objects, the keys are basically always strings, but in maps, we can have any type of key. It could even be objects or arrays or other maps. So that can lead to some really great and advanced stuff. So let's create a restaurant map here. So I'm just calling it rest here. And so we again use the constructor just like we used for the set, but this one called map. And the easiest way to create a map is to actually create an empty map just like this, without passing anything in. And then to fill up the map, we can use the set method. And then here we pass in two arguments. The first is the key name. So let's call it name, and then the name of the restaurant itself. So Classico Italiano. And so you see that this set method is pretty similar to the add method that we had in sets. So both allow us to add a new element to the data structure. And remember that we can use any data type that we want. So let's say that the restaurant has two locations. So we can create a key with a number. It doesn't have to be a string. So let's say one is in Firenze, Italy, and the other one, so a number 2, is in Lisbon, Portugal. And calling the set method like this does not only update the map that it's called on, but it also returns the map. So let me show that to you here. Okay, so this is what the set looks like after adding this key number 2. So here we have the entries. The first is name, which is then mapped to Classico Italiano, and then the other two that we just added. Now, the fact that the set method actually returns the updated map allows us to chain the set method like this. So let's set categories here as an array, and I will just grab that from up here. Okay, so once more, the value can be anything. And now I can just chain the next set on here. So I can now say open and set it to 11. And then again, I can chain the next one and say close at 23. So let's save it. And this will then format this nicely. So again, calling the set method returns the updated map. And so all of this is now the updated map. And so we can call set again on that map. And we can continue this even further. So let's now actually even use Booleans as the key here. And we can say that we want to map true to we are open. And then we can also set false to we are closed. And we will see in a minute how this can become useful. Okay. Now, in order to read data from a map, we use the get method. And so that get method is available on all the maps. And so all we need to do is to pass in the name of the key. So let's see. Let's log this to the console actually. And let's just duplicate it here and also log true. And you see that the true key here is then mapped to we are open and named to Classico Italiano, of course. And here, when we get the elements, of course, the data type of the key matters. So if we tried true the string, then that would be undefined. And if we tried to retrieve 1 as a string, that would also be undefined, because here we have 1, the number, as the key. And so with this, we will then get Firenze, Italy. All right. Now, just for fun, let's use the fact that we can have Boolean keys. So this true and false here, right? And we also have the open and the close time. So you see they are all kind of related. And so let's create something fun with this. So let's say we have some current time, and we could actually get the current time from JavaScript, but we don't know how yet. So let's just say it's 21 hours. So that's 9 p.m. And then we could do something really clever like this. So rest.get. And so when we pass in true, then we will get we are open. And when we pass in false, we will get we are closed. And so in order to get the correct string here according to the time, all we need to do is to compare the current time with these two open and close. Okay? So let's do that. We can say, or we can ask, is the time, so the current time, greater than rest.get open? And at the same time, is it below rest.get close? So basically here we are asking if the current time is between 23 and 11. And so this here is a true-false value, and this is a true-false value, so Boolean. And so the result of this AND operation will be either true or false. And then true or false will map to one of these values. So that's really clever, right? So let's log the result to the console. And let's check it out. And so at 21 hours, we are open. And that makes sense. It is between these two times. But if it was like 8 hours, then we are closed. Amazing. Now this is, as I said, pretty clever, but it's not really so readable. So don't overuse this kind of pattern, okay? This just really goes to show the power of having Booleans as map keys. But anyway, let's now keep exploring the methods that are available on maps. So we already have methods to set and to get. Now we can also check if a map contains a certain key. So let's log to the console the result of calling the has method. So categories. And so this should be true. And it is indeed true. Then we can also delete elements from the map. And again, that happens based on the key. So rest.delete. And let's say that the second location should be closed now. So this one here, the one in Lisbon. And so we take that key and delete it from the map. And as a result, that will then be gone here. So you see, no longer there. Now comparing this to objects, we can actually also delete properties from objects using something called the delete operator. But that's a really slow process, and usually it's not encouraged to do that. Here about the has method, actually objects do also have a method, which is called hasOwnProperty, but we're going to talk about that in the object-oriented programming section. All right. Next, maps also have the size property. So rest dot size, of course, and that should be 7, as we can see here. And yeah, so it has 7 items. And then to finish, we can also clear, so basically remove all the elements from the map. Let's just put that here. And so now it's gone and it has a size of 0. Let's put that back. So as you can see here, there is some overlap in the way that we work with maps and sets. And that's because they were both introduced in ES6. And now just to finish, let me show you that we can, in fact, use arrays or objects as map keys. So let's here set something else. And so now as a key, I will use this array. And I will set it to test. Okay. And let's just put that actually here, so it's before the log, so we can take a look at it. And so here indeed we see this is now the key, this array. All right. But now to get the data based on that array, let me see how we could do that. So rest.get, and think about what we are doing here. Do you think that this will work? And actually we need to log it to console. But given what we learned in the previous section about how JavaScript works behind the scenes, especially primitives versus objects, do you think that this will now retrieve test? Well, let's see, and no, it did not. And the reason for that is that these two arrays are actually not the same object. So this array and this one, even though we wrote them in the same way, and so they have the same elements, they are not the same object in the heap. Okay? And the key here is exactly this object in memory, and not this one. And so this cannot work. In order to make it work, we would have to do this. Creating an array, 1, 2, and then we use that array. And then we also use the same array to read the value out of the map. And so now it is going to work. Okay, because now, of course, these two refer to the same place in memory. Great. And so with this, we proved that we can indeed use objects as map keys. And this can be very useful with DOM elements, which in fact are also nothing more than just a special type of object. Let's do that here as well. Let's do rest.set. And now as a key, we will use document.querySelector. And then we're going to select this h1 element that we have here. So this is just an h1. So nothing fancy. And so the result of this will be an object. And so let's say that this is the heading. And now as we check it out here, you will see that it is here indeed. So as I hover it, you can even see it here visible on the web page. You see that? The highlight up there? That exactly is the key of this map entry. Sounds crazy, but it is possible, and it can enable some advanced functionality. All right, so we learned here how to create maps and how to work with them. So this should be enough for one lecture. And so let's wrap up this one now and continue learning about maps in the next one. So let's continue learning about maps. So in the last video, we created an empty map and then added elements to it by using the set method. Remember? However, there is actually another way of populating a new map without having to use the set method. And I prefer that because the set method is a bit cumbersome when there are a lot of values to set. So instead, we can create a new map like this. So I'm going to call this one question, because now we're implementing something like a quiz. So in a very simple way. So new map, and then here we can pass in an array. And this array itself will contain multiple arrays, and in each of these arrays, the first position is going to be the key, and the second position is going to be the value. So let's do that. So let's say question, and then what is the best programming language in the world? So this is basically the first entry of this question map. So before we would have used the set method and then this as the first argument and this as the second. But now we can simply specify this array of arrays in this way. Now, next up, I want to specify the options for the answer basically. And so I can simply do that by their number. So the first answer is going to be C. So C, the programming language. The second will be Java. And the third will be, of course, what else? JavaScript. Then we need a key for the correct answer. And what do you think the correct answer is? Of course, number 3. And then we can also have like a success message and an error message. And so let's again use the Boolean keys. So true, which is basically when the user is correct. Then we can say correct. And maybe some kind of emoji here, like this one. But if it's wrong, so if the answer is false, then try again. All right. And so let's take a look. And that looks correct. Fantastic. So when creating a new map from scratch directly in the code, I actually prefer this way of writing it over the way that we did in the previous lecture. But when we keep adding new elements programmatically using code, then of course the set method is still the way to go. Now, as an aside, does this kind of structure here, so this array of arrays, look kind of similar to you? Well, I hope it does, because this is exactly the same array structure that is returned from calling Object.entries. So for example, on the opening hours object. And so you see that there too, we get an array of arrays, where the first element is the key and the second one is the value. And so what this means is that there is an easy way to convert from objects to maps. So let me write that here actually. Convert object to map. And so we can say hours map is a new map. And then simply with Object.entries of opening hours. All right. So again, because this structure that results from Object.entries is exactly the same as this. So an array of arrays. So indeed, now we have a map here. And so keep this small trick here in mind whenever you need a map when you already have an object. Next up, let's talk about iteration. And iteration is possible on maps because, as we already know, maps are also iterables. And so the for loop is also available for them. And so let's use a for loop actually to now print just these options here to the console. So these 3, all right? So as always, I like to start with first saying what we will loop over. And so that's going to be the question map. And so each item of the question will, just like before, contain both the key and the value. And so here I can now directly destructure that into two separate variables. So this is a really, really good use case of destructuring. All right. So just to reiterate, this is exactly the same as we did when we looped over the object. The only difference is that for the object, we needed Object.entries right here. And that's just because the object is not an iterable. But then we converted it to an iterable using Object.entries. And so then this part here is exactly the same. Okay. Now keep in mind, we only want to print these three. So essentially, we only want to print an element if the key is a number. So let's use what we already know. Type of key equal number. And only then log to the console. So inside here, answer and then the key. So the number for the person then to choose with the correct value, which is going to be the answer option itself. So here we go. Answer 1, 2, 3. And now let's just also log the question itself. So quiz app. And here we want question.get, remember, and then the question key. And so now it is complete with question and answers. Now to get the answer from the user, let's again use a prompt. So answer equal prompt. And let's ask for your answer. And answer. And remember, we need to convert this now to a number, because eventually we will compare this number with the key that we have here. All right. Let's just print it then also. Okay. So here we have the question. And of course, the correct answer is number 3. And so here we go. And now we can use the power of the Boolean keys here in order to print either the success message here or the error message, basically. All right. So do you think you can do that on your own? Just take a minute or two and try that on your own right now. So did you manage to do that? Well, let's start by comparing the answer with the correct answer, basically. So that is question dot get correct. And so this is 3, right? And then we can compare that to the answer. So in this case, this was also 3. And so this here would return true, correct? And now since this is true, we can directly plug that into the map. And so this true will then return correct. So that's similar to what we did in the previous video as well. And so again, we are using the power of having Boolean values as keys. And then let's just log that final message to the console. So 3 again. Oh, and something went wrong. But I see that it's just here. It's the name. So this is correct, not correct. So again, 3. And now indeed we get correct. Okay. So this is 3 here. The answer is 3. This is 3. And so this here will be true. And so when we get true from the map, we get this string. Now, something else. And indeed, we get try again. Okay. And with that, we finished this nice little quiz. Now, just to finish here, as a side note, sometimes we also need to convert a map back to an array. So basically to this structure. And we can do that like this. So convert map to array, basically, you can do that by simply building a new array and then unpacking, again using the spread operator, the question map. It's asking us here again. And so then the result is essentially this same data structure, so the array of arrays with which we started. So it's this one here. So in this case, of course, this wouldn't make too much sense, but it's still good to know that sometimes you can convert a map to an array. Let's just preset this here to some value so that it doesn't always bug us here. And by the way, there are also the methods that we had on arrays, which are the entries and also keys and values in case that you need them. Okay, now they give us this weird iterator here. So then, just as I showed you before, you have to spread them and put them in a new array. So like this. But this is not really that important. I just wanted to show you that this exists. And for this, there's actually no need, because it's going to be exactly the same as this one. Okay, so these are all the keys and all the values indeed. All right, and that's all I have to show you about maps for now. But now you might be wondering, when should I use maps and when should I use objects? Because they are pretty similar, right? Well, that's what the next lecture is all about. There I will help you to choose between all the data structures, including even arrays and sets. Dealing and working with data is the main thing that we do as developers. And that's the reason why, since the beginning of the course, we have been working with JavaScript's built-in data structures like arrays and objects. Then in the last few lectures, we learned about two new data structures, which are sets and objects. So now we have 4 data structures from which we can choose. And so I decided to create this quick lecture, which will show you the pros and cons of each data structure and also when to choose each of them. And I want to start this video by quickly categorizing where data can actually come from. So there are essentially 3 sources of data. First, the data can be written within the program's source code itself, like status messages that will be displayed on a web page based on user actions. Second, data can come from the user interface, so from the web page. It can either be data that the user inputs into some form, or data that's already written somehow in the DOM. For example, this can be the user's tasks in a to-do app, or expenses in a budget app, or anything like that. Finally, data can come from external sources, which is usually a web API. Now, what is a web API? Well, API stands for Application Programming Interface, and we can basically use a web API to get data from other web applications. For example, we can use a web API to get the current weather in any city, or data about movies, or currency conversion rates, and really every kind of data that you can imagine. And we will learn how all that works later in the course. So no matter where the data comes from and what kind of data it is, we usually always have collections of data that we then need to store somewhere. And so where do we store collections of data? That's right, we use data structures. But as you know, there are 4 built-in data structures in JavaScript. And so now we need a way of deciding between them. But it's not that hard. So the first decision is this. Do we just need a simple list of values? If so, then we're going to use an array or a set. But on the other hand, if we need key value pairs, then we need an object or a map. So the big difference here is that with a key value pair, we have a way of describing the values, so by using the key. On the other hand, in a list, like an array or a set, we simply have the values without any description. Okay? Now, as a quick example, let's go back to getting data from a web API, because in modern JavaScript applications, that's usually the most common source of data. So data from web APIs usually comes in a special data format called JSON, which looks like this example here. So JSON is essentially just text, so a long string, but it can easily be converted to JavaScript objects because it uses the same formatting as JavaScript objects and arrays. So here we have three objects that describe recipes. We have the values in green, like the title and the publisher, and it makes complete sense that these values are then described using a key. Otherwise, we would have no idea what the different values actually are, right? So key value pairs are essential here, and that's why this data is stored in an object, not an array. Now, each of these recipe objects in itself can be seen as a value, and since we have many of them, it means that we have again a collection of data, and therefore we need a data structure to store them. Now, do we want to describe each of the objects? Well, it's not really necessary, is it? We already know they are all recipes, and whatever information we need about the recipes is already stored right in each of the objects. So all we want is basically a simple list where all the recipes are held together. And so here, an array is the perfect data structure for that. And in fact, creating an array of objects is extremely common in JavaScript. Now you will be working with this kind of data all the time as a professional JavaScript developer. And that's why I'm placing so much focus on this here. Okay, now before we move on to compare arrays, sets, objects, and maps, I quickly want to mention that there are also weak sets and weak maps data structures in JavaScript. Also, there are even more data structures that are used in programming, but which are not built into JavaScript. And just to mention a few, these can be stacks, queues, linked lists, trees, or hash tables. And these don't really matter for now, but I still just wanted to let you know that there are more than just the 4 built-in data structures. But now let's talk a bit more about the built-in data structures. So you already know at this point how to use all of them, but it's important to know when to use them. So starting with arrays versus sets, we already know that we should use them for simple lists of values when we do not need to describe the values. Now, you should use arrays whenever you need to store values in order and when these values might contain duplicates. Also, you should always use arrays when you need to manipulate data, because there are a ton of useful array methods. Now, sets, on the other hand, should only be used when you are working with unique values. Besides that, you can also use sets in situations when high performance is really important, because operations like searching for an item or deleting an item from a set can be up to 10 times faster in sets than in arrays. Now, one great use case for sets is to remove duplicate values from an array, like we already did before. So sets are really not meant to replace arrays, but rather to complement them whenever we are dealing with unique values. Okay, so now let's talk about objects versus maps, and we already know that we should use these key value data structures whenever we need to describe the values using keys, right? But when to use objects and when to use maps? Well, objects have been the traditional key value data structure simply because we didn't have maps before ES6. But using objects simply as key value stores has a couple of technical disadvantages. And that's why some people say that we've been abusing objects for this. Now maps, on the other hand, are way better suited for simple key value stores, because they offer better performance, in fact. Also, map keys can have any data type, and they are also easy to iterate, and it's easy to compute the size of a map. However, the biggest advantage of objects is probably how easy it is to write them and to access data by simply using the dot or the brackets operator. Also, most developers are already super used to objects, and so they simply keep using them for simple key value stores. Anyway, as a conclusion, you should use maps when you simply need to map keys to values, and also when you need keys that are not strings, because as we saw in the last video, that can be very powerful sometimes. Now, if you need functions as values, then you should absolutely use an object for that. So in objects, these functions are then called methods, and you can use the this keyword to access properties of the same object, which is impossible in maps. Also, when working with JSON data, as we saw in the previous slide, you will probably be using objects for that as well, unless you then want to convert the objects to maps. But that's usually not something that we do. So, in fact, we still use objects all the time, but maps are also a very important data structure right now, and way more important than sets. Great, and with that, we wrap up this overview. I hope you found this useful, and so let's now move on. And now it's time for coding challenge number 3. And we are still working on our football betting application. Now this time we have this map down here, so this one, which contains all the events that happened during the game. So the values here are the events themselves, for example a goal or a substitution, and the keys are the minutes in which the event occurs. And just notice that a football game has 90 minutes plus some extra time. So this might be a little bit over 90, but usually it's always 90 minutes, in case you're not familiar with this beautiful game. Anyway, your tasks are to create an array called events, which will contain all the different game events that happened during this game. And that means no duplicates in that array. Now, after the game has finished, it was found that the yellow card from minute 64 was unfair. So please just remove this event from the log. Next up, print this string to the console. An event happened on average every 9 minutes. And of course, your task is to calculate this 9 minutes, keeping in mind that a game has 90 minutes. Finally, loop over the events and then log them to the console. And what's tricky about this is that you should mark whether they happened in the first half of the game or the second half. And the second half means that it happened after 45 minutes. So it should look something like this. So I believe that this challenge is a little bit easier than the previous one, and so hopefully you can manage to complete all of these 4 tasks. So I see you once you're done. So I hope that was fun. So let's get started immediately with the solution here. So we should create an array called events with the unique events. So basically, that's the unique values of all of these here. Now, what are these values here? They are essentially the values of this map, right? So what I'm saying is that they are game events dot values. And we learned about this one kind of by the end of the last video. So let's comment out this one here. And so indeed, we see that this is what contains the values that we are interested in. All right. So let's say game events dot values, and this is our starting point. And now to get the unique values here, we basically need to create a set out of this, right? That's the main use case of sets. So, new set, but this alone is not going to be enough, but let's still take a look at this for now. And beautiful. So indeed we have a set with the only 4 events that happened. So there were only golds, substitutions, yellow cards, and red cards. And now to convert this to an array, we do it just like before. Create a new array and a spread operator to unpack this set. And then we are done. Next up, this one is the easiest one. So it tells us to delete the event from minute 64. So that's very easy. So game events dot delete. And now all we have to do is to use that exact key, and then that event will be gone. Great. The next one is just as easy, I believe. So let's just grab this from here. And now we just need to calculate this actual average. And how do we do that? So basically, to say that an event happened every X minutes, we simply need to divide the number of events by 90 minutes. So the duration of the game. So we see here that we have 3, 6, 9, 11 events. So how can we count that programmatically? Well, for that we have game events.size. Remember? And now we just divide that by 90. And with that we get this weird number. And that's because, in fact, we need the opposite. So we need to say 90 minutes divided by how many events there happened to say that on average something happened every 9 minutes. Now, if we wanted to be really specific, then this game actually lasted 92 minutes. So how do we get that value? So this is just a bonus. Okay, I didn't expect you to do this one. So this 92 is essentially the last of the keys of the map. So let's get the keys. So that's game events dot keys. And as always, we need to convert this to an array. So using all the tools that we already learned. So just to make sure, indeed, it is. And now we want the last value. And how can we get the last value? Do you remember that? Well, we can use the pop method. And in the past, we mainly used the pop method to simply delete the last element of the array. But also back then I told you that this also returns that deleted array. Or actually that deleted element. And so here we can take advantage of that. So this here is an array now. And so on that we can call pop. And so that will take the last element out of the array and give it to us. So that's 92. And so to make this really accurate, here we can now say time. Okay, and so this is even better right now. But again, this is just kind of a bonus just to show you some more nice little tricks. Anyway, now our goal is to loop through the object, or actually through the map. And so this is pretty standard now at this point. Now here we are missing the off. So just like we did in the last video. And now all we need to do is to figure out the half. So if it's the first half or the second half. So what we want to log to the console is this. And then so either first or second half. And then the minute I believe. Let's see. Yeah, so the minute and then colon and then the event. So let's actually make these here more specific. So minute and event. So that makes it easier to read the code. So minute and event. And now here let's just again create an external variable, which I'm going to call the half. And let's use the ternary operator here again. So if the minute is below or equal 45, then it is the first. Otherwise, it's the second. And that's it. And that worked just fine once again. Okay. So I hope that made sense. In case it didn't, then as always, just analyze the code, or you can also just ask some questions in the Q&A area. Anyway, we're now almost done with this section. Next up, all we have left to do is to work with strings, which is also a really nice and really interesting topic that we need in JavaScript all the time. So make sure to follow me there right away. Over the next few lectures, we will learn how to work with strings. And so we're going to be taking a look at a couple of useful string methods. Now, I could have divided this part about strings into many more lectures and go really deep into some topics, but I think it's best to just quickly introduce you to all the topics here and then keep using them in future projects, because we work with strings all the time in JavaScript. And so you will see these methods being used all the time throughout the rest of the course. Anyway, this is going to be really fun, so let's get started. And in this part of the section, we're going to leave the restaurant theme behind and work on stuff related to airplanes and airlines. So that's something that I really like. So let's now start by creating an airline variable here. And I'm using tab air Portugal. All right. And if you want, you can use some other one from your country maybe. But then you might have to adapt the examples. So as a plane, I'm using a string A320. Okay. And now let's do some stuff with this. So just like in arrays, we can get the character of a string at a certain position. So for example, plane at position 0 should be A, right? So let's load this here, and indeed we get A. And the same, of course, for all the other letters, 1, 2, for example. And so indeed, you now get 3 and 2 here, but both of them are still strings. So if we wanted them to be numbers, we would have to convert them. And we can do the same directly on a string. So we can just write a string, and let's write B737 now, which is a Boeing. And so this works the same. Okay, so now we got the B. We can also read the length property of strings, just like we can in arrays. So let's say airline.length. And again, we can also do that directly on the string. Okay, there you go. Next up, let's talk about methods. So again, comparing strings to arrays here, strings also have methods. And some of them are quite similar to the array methods. So one of them is the index of. So I believe we talked about this one when we talked about arrays. And so this one works the same way. So we can get the position in which a certain letter is in the string. So let's use R here. And so here we now get the position number 6. And so let's see, 0, 1, 2, 3, 4, 5, and 6. Okay, and that's where this 6 here comes from. So you see that strings are also 0 based, right? And we could observe that already up here. Now this here will only give us the first occurrence, but sometimes we might need the last one. And so then we can use last index of. Last index of. And so that is 10. So this one was 6, then 7, because the space, of course, also counts as a character. Then 8, 9, and this is position 10. All right. And we can also search for entire words. So, for example, for the occurrence of Portugal. And so that is at position 8. And this one is actually case sensitive. So if I search with lowercase, then we get -1, because this can now not be found in this airline string. All right. Now, what can we actually do with these indexes? Why are they useful? Well, one good use case is to extract part of a string using the slice method. And the slice method needs indexes as arguments. And so therefore, sometimes it can be very useful to first figure out the index of part of a string to then extract that. So let's see how the slice method works. So airline and then dot slice, and let's write 4 and see the result here. All right, so the result is Air Portugal. And the reason for that is that this here is the begin parameter. So basically it's the position at which the extraction will start. And remember that this is 0 based. So 0, 1, 2, 3, and 4. So 4 happens to be this A, and so this is where the slice method starts to extract. And now this result that we get here, so just this here, is called a substring, because it's just a part of the original string. Now this does not change the underlying string, okay? Just keep that in mind. That's because it's actually impossible to mutate strings. They are primitives, right? So if we wanted to use this string now, we would have to store it first into some variable or some data structure. Okay, so this method here and all the other ones that we're going to talk about always return a new string. Okay, and so that's why we can then log that result to the console like this. Now, besides the begin parameter that we already specified, we can also specify an end parameter. So let's try 7 and see the result. And so now we only got air. Okay, so this one is 4, then 5, 6, and 7 is the space here. And so what this means is that the end value is actually not included in the string. All right, so basically it stops extracting before reaching index number 7. And that's really important to keep in mind. And just as a side note, the length of the extracted string is always going to be end minus beginning. So 7 minus 4 is 3. And so that's the length here of air. All right. Okay. Now, up until this point, we have always just hard-coded these values. But of course, many times we don't even know the string that we receive yet. Okay. And so let's now try to extract just the first word of this string here, but without knowing any of the indexes. And so that's where this index of and last index of here become really important. So basically that we do not have to hard code these values here. All right. So let's try to extract that first word, as I was saying. So airline.slice. And now we need to figure out the index. And now if we want the first word, we need to start at 0. But what about the end parameter? Well, we want to extract until this space here, basically. So let's find the index of that. So airline.index of, and remember that this will be the first occurrence. And so, indeed, we get top. All right. And now let's do the opposite, extracting the last word. So slice. And so for the last word, we want to start at the last space here. Okay, that's why we have last index of. So airline dot last index of, and again searching for the space. And now we don't need the end parameter because then if we don't specify it, it will simply extract everything until the end. Okay, but actually now the space is also included here. And so we just need to add +1, and now we're good. So that's the fundamentals of the slice method, but we can do even more with it. So let's go again here, and we can even define a negative begin argument, like this, for example, and then it will start counting from the end, or actually start extracting from the end. So these are the last two letters from Portugal. And finally, let's duplicate this one again. And again, I'm using this shortcut here for duplicate. Okay. So we can also specify a negative end parameter. So the begin is back to positive, and now the end is -1. So let's see. And so basically we started at position 1. So that's why the T is cut off. And then the negative end parameter basically cuts off the last character. All right. And so we will need all of these different combinations here in different situations. So it's good that you know how to use them because you will need them at some point. Okay. And now let's practice a little bit what we just learned and write a function that receives an airplane seat and logs to the console whether it is a middle seat or not. So I hope that sounds like fun. So let's write check middle seat, and it is a function which takes in a seat. And just to illustrate it, let me start by calling this function. So check middle seat. And so typically an airplane seat looks like this. So we have the row as a number here, and then the seat itself, so that's like the column, so to say, is then a letter, for example, a B. So it starts from the left and goes all the way to the right side. And in small planes like the A320 or the Boeing 737, we only have 6 seats in one row. And that means that B and E are the middle seats. Let me just write that here. B and E are middle seats. So just in case you're not familiar with how these small planes work, right? And that's also not the point here, of course. So basically all we want to do is to check if the string that we receive contains a B or an E. And if so, then it's a middle seat. And let's call this with a couple of different strings. So 23C and 3E. All right. So what we need to do here is basically take the last character of the string and test whether it is a B or an E, right? So let's get that letter from the seat. Now we'll just call it S for seat again, but I cannot repeat the same name here. So how do I do that now? Well, to extract part of a string, we already know we use the slice method. And how do we take the last character of a certain string? Well, we use -1 as the begin character. And then, as we saw up here, it will start counting basically 1 from the right side. And now it's very easy. If S equals B, or if S equals E, then let's log to the console. You got the middle seat, which is the one that no one wants. Well, let's add an emoji here. Let's say this one. Or else, you got lucky. Just any emoji here, just to make it different. And I think we are good now. Let's test it. And so indeed, this here contains the B at the end. And so therefore it's a middle seat. The same for this one. And this person with this seat got lucky. All right. And that's how we extract parts of strings. And that's something really important to do. So maybe if you'd like, you can play around with this some more, maybe come up with your own example. Now, before we move on here, let's just stop for a second and understand why all of this actually works. So we know that strings are just primitives. So why do they have methods? Shouldn't methods only be available on objects such as arrays? Well, that is actually true. However, JavaScript is really smart. And so here is how this works. Whenever we call a method on a string, JavaScript will automatically, behind the scenes, convert that string primitive to a string object with the same content. And then it's on that object where the methods are called. All right? And this process is called boxing because it basically takes our string and puts it into a box, which is the object. So basically, what happens is this. So what JavaScript does is to call this string function here. Okay, and so now you see that this string here looks a little bit more like an object. And we could take a look at this here. And so you see here all of these methods like slice that we just used. But this is beyond the scope of this lecture. We will learn what this is a little bit later. But what matters is that this indeed is now an object. So you see, it is an object. And so this conversion here is what JavaScript does behind the scenes whenever we call a method on a string. And then when the operation is done, the object is converted back to a regular string primitive. Okay? And in fact, all string methods return primitives, even if called on a string object. So let me demonstrate this here as well. Just really quick. And actually we want here type of. And so the result of all of this is then back to being a string. Okay, but don't get confused by this. This is just the theory explanation behind why all of this works, in case you're curious. And I hope you are. Great, but now let's move on to the next video where we will continue working with strings. Let's continue with some simple string methods. And the first two are going to be for changing the case of a string. So that's airline dot to lowercase, and this doesn't require any arguments at all. And then we also have to uppercase, and these we use all the time, as you will see soon in a more real world example. And here you see that indeed they transformed the string all to lowercase and to uppercase. And again, you can of course call these directly also on a string. So like this. All right. But now let's use this on a more practical example to fix the capitalization in a passenger name. In name. Okay. So let's say that the passenger, when he checked in, misspelled his name. And so it looks like this now. And so this needs to be fixed. It should look like this. Okay? So in order to fix it, the first step is usually to put everything into lowercase here. So const passenger lower is passenger dot to lowercase like this. Okay, so basically we already have now this part here, and now all we need to do is to essentially take the first letter and then the rest of the string and put these two parts back together. So passenger correct will be passenger lowercase, and here we only need the first letter. So how do we do that? We take the first letter by using the index 0. And so this one we now convert to uppercase. All right. And now we simply need to add the rest of the string. So again, we take passenger lower, and then we use the slice that we learned in the last lecture and start at position number 1. Because remember, that will then go to index 1 and take everything until the end of the string. And so here we then put back together just the first part of the string converted to uppercase here, and then the rest of the string that we already had converted to lowercase before. Okay, and indeed, now it is corrected. Great. And of course, we could have done a function with this. And so maybe if you have the time, you can do that. So just create a function which takes any passenger name and then returns the correct one. So with the fixed capitalization. But anyway, I will now do another real life example, which is to check a user input email. Okay, so check email. Now this will not be really a checking, it will more be a comparing. So comparing emails. So let's say that we have the email of one passenger. So hello@jonas.io. But now as the user logs in, so let's say login email, accidentally they do it all wrong. And they start with a couple of spaces here. And then the capitalization is all completely off, like this. And then maybe even another space, or even an enter character, which remember is \n. So I think we talked about that in the beginning. Okay. But still, this email here is actually still kind of correct and kind of valid. And so we can now still compare if these two are kind of the same. Okay, so we can now try to convert this one to this one and then check if they are the same. Because essentially, again, they are. They would be different if we had like different letters here. Then of course they would not be the same. But here it's just a matter of capitalization. And for emails, I believe that they are still valid even with the capitalization off. And so when we check user input like this, the first step is usually to convert it to lowercase. So lower email is login email dot to lower case. And then we must also get rid of all the white space here. So these empty spaces and also this enter basically here also counts as a white space. So there is even a method for that. So let's say trimmed email. And so that is lower email dot trim. All right. Let's just now log this to the console just to see. And so that looks exactly like that first version. Now, just look closely at what we did here. So we called to lowercase on this login email, stored it to this variable, and then on that variable, we called the trim method. But why do we even need this intermediate email? We could do this all in one step. So basically, we can replace all of this, and let's call this normalized email, actually. And so again, I will start from login email and then do it all in one step. Dot to lowercase. And now this is a bit similar to what we did before with the map set method. So this here will return a new string, right? And on strings, we can call string methods. And therefore, right here, we can now immediately call the trim method. Okay, so normalized email, and that should look exactly the same. And it does. So let's get rid of this. And these two I will simply leave as a comment here. And now just to finish, let's actually also compare them for the sake of completion. And once again, you could do this here in a separate function. So you could do a function for this behavior where you pass in two emails, one which is the correct one and one which is the one to check. And then you could return either true or false from that. So again, that sounds like a good challenge that you can take if you want. And by the way here, since ES 2019, there's also trim start and trim end, which as their names say, you can use to trim whitespace only from the start of the string or only from the end. Next up, let's learn one of the most important things about strings, which is to replace parts of strings. So replacing, okay? And we're gonna stay here again with the airlines. So let's say we have the price of a flight, and that price is for Great Britain. So let's say 288,97 pounds. And you can use any other currency sign that you want here. What's important is that here in Europe, we use the comma as a decimal separator, unlike in the US, where you use the period, so the dot. And so that's actually what we're going to do now. We want to compute the price in US. All right. And so for that, we will need to replace the pound with the dollar sign and the comma with the period. So that's easy enough. Price Great Britain dot replace. And now here two arguments. The first one is the one we want to replace. And let's start here with the pound sign. And the second argument is the string that will replace the first one. So let's take a look. Price US. And so that already worked. And now we need to replace also the comma with the period. So we could create another variable now, but instead we will do chaining again, just like we did before. And for the same reason, because this returns a string. And so on that string, we will immediately call the next replace method. And now we are replacing the comma with the dot. And so, indeed, now we have the price in US. Okay, but indeed, we can also replace entire words, not just single characters. So let's create an announcement that you would typically hear on the airport, like all passengers come to boarding door 23. Boarding door 23. However, usually it is called gate and not door. And so let's replace that and log the result to the console immediately. Because just like the other method that we studied, replace also creates a brand new string. It doesn't mutate the original one. And so here it's the same. And so we need to log the actual result to the console. So replace door with gate. And here it's boarding. And now let's check it out here. So here, boarding gate, but then here you actually still have boarding door. And so this replace only replaced the first occurrence of this search string here. Okay? And actually that's completely normal. That's just how it works. But we can still go around this. Now, very soon, JavaScript will have a method called replaceAll, which will work like this. But right now, here it should not work yet. And indeed, I get here, replaceAll is not a function. But if you're watching this video in the future, then this here might already work for you. So please go ahead and try it out. All right, but for me it doesn't work yet, but there is still another solution, which is to use something called a regular expression. Now, regular expressions are one of the most complex and confusing topics of programming, but we will still take a short look at them at some point in the course. But for now, we are just going to use a very simple regular expression to tell the replace method that it should actually target all the occurrences of door here and not just the first one. So let's again copy this here. And then to create a regular expression, we need to write the string between slashes. So not between quotes. So it turned yellow here again, which means that it's some kind of string, but it is now a so-called regular expression. Then in this case, all we want to do with this regular expression is to add this G flag here. And this stands for global. And that's actually it. So right now, all the occurrences will be targeted. And so we replaced gate here and here. All right. And just as a side note here, once more, the replace method is of course also case sensitive. So just like all of the other string methods are. Okay, and now as a final topic of this lecture, there are three simple methods that return booleans. So booleans, okay? And these methods are includes, starts with, and ends with. So let's create a new plane here. And that's going to be the A320 Neo. And I'm just missing here the assignment. And now we can simply use includes just like we can in arrays one more time. So they have a very similar structure here in terms of methods that we can use on them. So includes, and let's test if it includes the string A320. And indeed it does. So this airplane here is the Airbus 320 Neo, but it still includes just the A320. Now, let's say if it includes Boeing, and of course it doesn't. And now there's another one, which is the starts with. And this one is also actually very much used. I remember using it very recently. And so in this case here, it is false. All right. But then if we change this here to Airbus, then it is indeed true. Okay. So these three letters here are indeed the first three also here. So it doesn't have to match the entire word. So just AI would also be true, but AI B, let's say, would then be false. Because of course the string does not start with these three letters. With Air B, then it would again be true. Okay? And of course this A320 is also still true as long as it is somewhere in the string. So now it's somehow here in the middle. Okay? So let's try something very simple here. So let's say that we want to check if the current plane is part of the new Airbus family. And so all we need to do to check that is to see if the plane name starts with Airbus, and we can already confirm that it is, right? And we also need to check if it ends with Neo, because that means that it's part of the new Airbus family. And so we can also use ends with. So as always, these methods here that return booleans are especially helpful for conditionals like this. part of the new Airbus family. And indeed, this one here is. But of course, if it was just the regular A320, then that would not get logged to the console. So whenever you need to take some decision based on the contents of the string, these three methods are very, very helpful. And let's now actually practice that a little bit with some kinds of, we can say a practice exercise. And so here we want to check if the baggage of a certain passenger is basically allowed to be checked in. So to be allowed on the plane. So check baggage function. And then here we get the items. And let me again first call the function to show you what I mean. So basically the passenger here says what they have. So I have a laptop, some food, and a pocket knife. Then let's call this again and say we have, or I have some socks and a camera. And then let's call it a third time with the string now, got some snacks and a gun for protection. Okay. So maybe some passenger would bring a gun to a plane. But so now let's make sure they will not get aboard the plane. And actually, let's change some things here. So let's make this uppercase. Let's say this person likes to write uppercase for some reason. Okay. And so this is important to show you once again that when we receive input from a user, we usually always start by putting everything into lowercase. Okay. Because that makes it a lot easier to then compare it to something. Well, let's simply say baggage here. And so baggage is basically items to lowercase. So this one we use all the time. And now we can just check if the baggage includes a knife or a gun. And in that case, the person is not allowed on board. So if baggage.includes, and so here is that method again, which returns a Boolean. So if it includes knife, or if it, so baggage includes a gun, then we say you are not allowed on board. Else, let's log welcome aboard. All right. And so now let's see here why it is so important to convert everything first to lowercase. So in this example here, this first person has knife, but with an uppercase. And so if we didn't convert this to lowercase, then this includes here would be false, because the lowercase knife is different than the uppercase knife. Okay, so let's see the result. And so indeed, this person has a knife, so they are not allowed. This person here is fine. And then this one has a gun. And so, of course, they're also not allowed. But now, if we took away this here, well, then our code is not really going to work. So let's just delete this part for now. So if we didn't have the two lowercase, then the first person would also be welcome aboard. And again, that's because knife here, uppercase, is different from this knife. And so then we would have to check for all the variations, like knife like this, or this knife, or even this. So every possible variation. And so that would be highly impractical. And so we just turn everything to lowercase. So again, so that we can then easily compare it with one standard, which is this and this. All right, perfect. So that was another fun lecture, if you ask me, and I hope you are feeling the same. Now it's time for a break, and I see you back here in the next video. This is the third and final part of working with strings. And let's start by learning about one of the most powerful string methods, which is split. So split allows us to split a string into multiple parts based on a divider string. So let's check that out. So any string works here. Let's say A plus very plus nice plus string. So let's say that for some reason we have a string like this. And now on this string, we can call the split method. Here we need to specify a divider string. So let's just use plus. And so what will happen now is that it will split up this string by this plus sign. And it will then store the results into elements of a new array. So let's see that. And indeed, we get an array which contains A and very and nice and string. So essentially everything split up by this divider string. So let's try the same with my name. Dot split. And so the goal here is of having one array with two elements, one for each name. And so I can split by the space. And this is a very common one. And so indeed, I get this result. And this is really useful. Indeed, we can now actually use the power of destructuring to create variables directly like this. So I can say first name and last name will be the results of this split. Okay? So this here will create an array with two elements. And then from that array, the first one is going to be taken into first name and the second one into last name. Okay. Now we could have done the same thing with the slice method, but that would have been a lot more complicated and for longer sentences almost impossible. And like this, it's really straightforward. Okay, now let's say that we want to make the last name uppercase here. And then we also want to add a Mr. in the beginning. So we could just use a simple template literal and do what I just said, but I want to show you something else here. And that's the join method, which is essentially the opposite of split. So let's create an array which contains all I just said. So we want to start with Mr., then the first name, and so that's going to be the second element of this array, and then the last name in uppercase. Okay, and now I want to join this. And again, we can specify a divider string, and hopefully you can see by now where this is going. So let's store the result of this into new name. And then let's check it out in the console. So what do you think will be the result of this? So of the join method. So indeed, we now get one entire string here. So one string composed of the three parts of this array and joined together by this joining string here, basically. And of course, we could have used anything else. So like this, or even like this. So anything works here. But what makes sense, of course, in this case, is just the space. So this combination of split and join is really powerful, and we will actually use this all the time. So split and join. Okay. And in fact, we can use this for something that we already did in one of the previous lectures, which is to capitalize a name. But now with this, it makes it really easy to capitalize an entire name with multiple names in there. So let's say that this passenger is called Jessica N. Smith Davis. So how will we capitalize this name here? And actually, let's write a function. So that's a bit nicer. So const capitalize name, which is a function which receives a name, and then it will do something with that. So let's capitalize name here with that string instead. And then we can also call it with some other name. So my name, for example, and you can use your own name here, of course. So what's the strategy for capitalizing this entire name? And by the way, what I mean here is to transform the first letter of each name into a capital letter. So here, Jonas, and then this one here, Schmettmann with this capital S. Okay. Well, we have multiple words here. And so we will have to capitalize all of them one by one. And so to do that, it would be good to have them inside of an array that we can then loop over. And so now we can use the split method for that. So let's say names is equal to name split by the space. And so this will be an array. And now we can then loop over that array using the for off loop. So const, let's just call this one word, of names, or let's call it n, which stands for name, but I cannot reuse name because that would then override this input here, and that's a bad practice. Okay, and so now here we will then capitalize this name. So this individual name. So remember how we did that in the last lecture? We took the first letter, converted that to uppercase, and then joined it with basically the rest of the word. So that's n.slice starting from position number 1. So everything except the first letter, which is letter number 0. Okay, and now what should we do with this? Well, I think we should push this into a new array so that in the end we end up with an array with all the names capitalized, and then we can join that array together. So let's say const names upper and start it as an empty array, and then in each iteration we will simply push into this array. So, sounds good to you? Okay. And now, in the end, let's then log to the console names upper. And so now we need to join that array back together using the space as a separator. Okay. So here we practice a lot of different methods all in one function. So this is a really great use case. So let's now give it a try. And indeed it worked. So great, right? No matter how long a name we feed into the function, it will always give us the correct output. Now, here is a small challenge for you, because there is another way of doing this. So basically of doing the capitalization of one name. So given what we already learned, especially in the last lecture, can you think of a different way of doing this? And if you can't, it's not a problem at all, but maybe you can pause the video here for a minute or two and think about this. So, let me just show it to you quickly, because I think this is really interesting, that we have different ways of achieving the same thing. And so this time, what will we push into the array here is simply n, and then in there we replace the first letter with the first letter in uppercase. So let me write that. So that's n at position 0 and replaced with n at position 0 to uppercase. Let's give it a try and we get the same result. All right. So again, we are here simply taking the word and then we replace the first character. So that's n at position 0 with the first character to uppercase. So that's a completely different approach than this one here, but it gives us the same result. Now, next up, let's talk about padding a string. Now, padding a string means to add a number of characters to the string until the string has a certain desired length. So, padding, and let's just create a message here. Go to gate 23. So now let's take a look at padding here. So I will take message, and then I can say pad start. And so this will then add some characters to the beginning of the string. And the first argument here is the length that we want for the string. Let's say we want it to be 25 characters long. So after the padding. And then the character that we want to pad the string with. So let's use plus, and let's take a look. Okay. And so you see that it added all of these here. And so now the length of this entire string here should be 25. Okay. So let me show that to you with another string here. So if I said Jonas and then the same, you would see that it would add a lot more of the plus signs because the initial string is shorter. So you see, we have a lot more pluses now, but in the end, the string is also 25, or actually 23, so mistake here. So now the string is also 25 long. And so we see here that this has exactly the same length as this one here in the console. All right. Then there's also pad end. And so we can now take the result of this and immediately also pad the end of the string. So pad end. And now let's make it longer. And then again the plus sign. So this will basically then add 10 pluses to the end of the string because the result of this string here is already 25 characters long, right? And so onto this one, we then pad it all the way until the length of 35 with some more pluses. And so we're going to add 10 of them. Let's just do 30 so we can easily see that. And so indeed, it now added 5 of them here. And just for the sake of completion, let's do the same here with my name. And this here just to 20 to make it a bit more even. All right. But now let's actually use a more real world example of padding here. So when you see a credit card number on the internet, you never see the entire number, right? So usually we see the last 4 digits and the rest is masked with some symbol. So let's implement a function that actually does that masking. So this is going to be really interesting. This is a great application of string methods. So mask credit card function. And so we're going to receive a number. Okay, so an actual number. And let's start by converting this number to a string. So string. Now we learned how to convert a number to a string in the fundamentals section, right? So that was like this. Remember? However, there is a nice trick that actually makes this easier for us. So we can just take the number and then we add an empty string. And so the result of this will be the number, but as a string. And this works because, as you hopefully remember, when one of the operands of the plus sign is a string, it will convert all the operands to a string. And so then this number will become a string plus the empty string. And so then it's going to stay exactly the same. Okay, so in order to know what we should do here, let's one more time first call the function before we actually write it so that we know what kind of input we get. So mask credit card, and let's say now the number is this one, and I'm just putting something random here. But of course, it will also work with strings. And no matter how long it is. All right. So, as I was saying, usually on the internet, we can only see these last 4 digits. And the rest is masked by some symbol. So what we need to do here is basically to take out these 4 numbers and then use pad start to create a string with the same length as this initial number here, but with some kind of symbol there. So let me just write that in code, and then I hope it will become clear. So we're going to take the last 4 characters of this string, and so we use slice with the negative parameter again of -4. And now here is what we're going to return. We will return a last, so that is just these 4 characters. And then we will pad it at the start all the way until the original length of the string. So string.length, and the character we're going to use will be this star. Okay? And so since we return something to make this function a bit more real, now we need to log the result to the console. And to start, let's actually make a slightly simpler version so that we see that it actually worked. So a shorter number here with just 8 digits. And so the end should be 7836, and then beginning with 4 stars. So let's see. And yeah, that worked great. Right? So again, we took the last 4 here, and then we padded the rest of the string until it matched the original length of the string, which was 8, and therefore 4 stars were added. And the same here, and the same here. Awesome. That's really fantastic application of this method, I think. And now to finish, the last simple method that I want to show you is the repeat method. So repeat. And as the name says, this one simply allows us to repeat the same string multiple times. So let's say there is some bad weather at one airport. So when that happens, they usually have those long messages on the screen, like with the text repeating, which then keeps running and repeating all the time. So let's call this one message. So let's call it message 2. We already have message up there. So let's say bad weather, all departures delayed. Okay. And now we want to basically create a bigger string, repeating this one here multiple times. So that's easy enough. We just take this string, call repeat, so repeat, and then the number of times we want to repeat it. Let's say 5. And there it is. So this is all the same long string. We should just add one space here at the end. And so you see, now you can see it even better, that it's all just one big string with the same message repeating over and over again. Or we can also simulate that due to the bad weather, there are now many planes waiting in line for takeoff. So let's create a fun function for that. So planes in line, and here the number of planes. So console.log, there are n planes in a line. And then here we can kind of show that graphically using an emoji like this. Let's say plane. I'm going to use this one. And so this here, in fact, counts as a string. So let's create a string with that and then repeat it. And we will repeat it as many times as there are planes waiting. So planes in line. Here we have 5 waiting. Then let's call it on another airport where there are just 3 planes waiting, and then 12. So indeed, now we have 5 planes, here 3, and here 12 planes. All right. Okay, cool. Now, we didn't talk about all of these string methods that exist, but if you want to check them out, you can do so on MDN. And what I like to do is to simply search for one of the methods, let's say string replace, and then that will take me to that page of replace, because then on the left side, at least when the window is a bit bigger, so then here we can see all of the different string methods that we can use. So we used split, slice, repeat, pad start, pad end. But as you can see, there are even more here. But actually, we talked about all of the most important ones. Maybe one that you can check out is, let's see, concat maybe, or there should one be called reverse. Well, actually, it is not here. But anyway, as you see, we talked about most of the most important string methods here. And so I hope you had fun with this. And I see you in the next video, where we then have a challenge where you can then use all of this knowledge that you just gained here over the past 3 videos. Welcome back to the last coding challenge of this section. And this one is going to be quite a bit different from the previous ones. So in this one, I want you to write a program that receives a list of variable names written in the underscore case, and your program should then convert them to camel case like this. Okay. Now the input will come from a text area that was inserted into the DOM using this code below here. Okay, so this code here created the text area, and this one the button, using the create element function, which you will learn about later. Okay, so that's where the variable name list will come from, and the conversion will happen when this button here is clicked. Okay, and here is the test data. So this is what you will take and paste here into this text area. And as you click the button, you should produce this output here. Okay, so 5 separate console.log outputs. So essentially 5 different results. Okay, so here are a couple of hints for you to solve this problem. So first off, you need to remember which character actually defines a new line in the text area. So I hope you can remember that. Then, the second one, the solution only needs to work for a variable made out of 2 words. For example, in this format, a_b. So that's exactly what we have here, right? Then number 3, start to solve this challenge without worrying at all about this here. Okay, because this actually is a little bit difficult. And so start by only creating this variable name in the camel case notation. And finally, I also want to let you know that this challenge is quite difficult on purpose. Okay, so once again, I really want you to challenge yourself. But in case you're stuck, of course, you should not get frustrated. Instead, you can just start watching the solution, and then if that helps you, you just pause and continue. Then, once you made it work with this test data, you can of course also use your own. So pause the video now and take all the time that you need, and I see you back here as soon as you're ready. Okay, and let's start by attaching an event handler to the button. So to this button here. So all we have to do is query selector, or actually document.querySelector, and then we just select the button element, right? and then add event listener for a click, and then a certain function. And the first thing that we need to do is to get the value out of the text area. And for that, I already put you this snippet of code here. So let's grab that. And just to start, let's log it to the console. So paste that here. And indeed, it is basically one big string containing all of this. All right. So how do we now separate this basically into 5 different strings to start with? Well, we remember which character defines a new line, right? Because that's going to be a great starting point to split up this string into multiple pieces. And so that's going to be, let's say, rows. And so that will be text.split. And that new line character is \n. So let's see. Let's log rows now. And so now we should get an array with 5 elements. And of course, we need to first paste it back here, click this button. And so indeed, we now have this result here as expected. And now let's just simply loop over this array, and in each iteration log this variable name here converted to camel case. So simple enough, for const row in rows. So first off, the first thing that we need to do is to, now I clicked here, now it's gone. But anyway, let's take a look at this case here. And indeed, let me copy it down here so we can always take a look at it while we are developing. Okay, so we need to, let me also write the result underscore case. So it should become this. So to do this, we need to first split this variable name here also in its 2 parts, which are separated by the underscore right now. So each word here is now called row, right? And so we split that by this underscore. But actually that is not enough, because as you know, camel case should be all lowercase except for this second word here, which should start with an uppercase. However, here actually we have some uppercase right here, and here even worse, this entire word. Also, we have some weird spacing going on. So here we have this space, here even 2 spaces, and so we need to get rid of both of these. And so just like before, we can use 2 lowercase, and then we can also use the trim method on that. And then we can even chain a third method, which is then that result of splitting it into words. Okay. So we end up with an array with 2 words. And so let's destructure that into 2 variables. So first and second. Okay. And then we are already well on our way to building the output here. So let's call it output, and it's going to be this string with simply the first word, because that's already good enough. And now we just need the second word capitalized. And we already did that a couple of times. And so let me show the second version that I showed you, which is simply, well, second dot replace. And what we want to replace is second 0, so the first character, with second 0 to uppercase. And then logging it to the console, and I think that's already it. So I wrote this here quite fast because I already explained everything before, but of course you can keep pausing the video to take a look at what I'm doing even more closer, and maybe also really analyze what I'm doing. Okay, now we get cannot read property replace of undefined. So what that means is that second is undefined. And so therefore, we are getting a weird result from this here, basically. So let's use some console.logs here. So let's log the row first and second, just to make sure, or just to see what's happening. And we can get rid of this console.log so it doesn't get in our way. Then paste that here, run it, and we get 0, 0 undefined. Well, that's weird. Everything looks correct. Oh, here, this should actually be off, not in. And actually there is an older loop called the for in loop, which I didn't show you because it doesn't matter anymore. But that's why we didn't get an error as I wrote the in here. So let's see if now it works. And now at least this result here makes sense. So this is indeed the row, this is the first, and this is the second. But now we get some other error here. So the two uppercase. And yeah, that's here because I didn't actually call it. So I just wrote the name of the method without calling it. So that was another bug. But this is one more time good to show you that bugs are actually a common thing in software development. Anyway, we see that actually our variable names are already correct. So all of them are converted to camel case. So let's get rid of that console.log here. And now let's tackle this last part here with these emojis here. But you could, of course, use any other sign. So two things to notice here. The first word has 1 check mark. The second one has 2 check marks, then 3, 4, 5. So that's the first thing. And the second thing is that they all start at the same position. So this means that all of these strings here basically should have the same length. Okay, and how do we do that? How do we give all of them the same length? Well, we can use padding, right? In this case, we use pad end and set them all to a fixed length. Okay, so let's do that here first. So pad end with a length of 20, and the string to pad should be simply an empty string. So let's see, and it will look the same, but as we select, we see that actually now the selection continues, which means that there is indeed some empty spaces there. And in fact, when we want just empty spaces, we can actually omit this second argument and just call with 20, and then the result is going to be the same. So then after that, let's just add the check mark. And so here we now need to return or to log a template string, which will contain all of that. So here the emoji, and yeah, okay is the way to go here. And so this should be almost now the correct solution. Let's see. Okay, so all the emojis now start at the same place. But now all we have to do is to add 2 here, 3, 4, and 5. And for that, we are going to use the current index in each iteration. Okay. Now remember how we can get access to the current index in the for off loop. So we're looping over an array here. And so to get the current index, we need to actually use the entries of the array. Remember that? So we say entries, and then here the row is now actually an array with first the index and then second the actual element. And so let's destructure that here right away. where I is the index and row is then the actual element itself. And then here we can use that index to basically repeat this string. So you see, this is a lot of work and it's quite a challenge again. So I didn't expect you to really make this on your own, at least not in a very fast way. Maybe you took some time and then you made it, and so then that's really great. But anyway, it's very good to challenge yourself and bring yourself to the limit too. Anyway, here we now took this string, and then on that string we called repeat, just like we did before with the airplanes. And then we want in the first iteration 1, and so that's going to be here 0 plus 1, because we always need to add 1 because it starts at 0. So give it a save, paste our variables here, and yes, that is the solution. That's amazing. Let's add another one here, Jonas SCH, and let's see. And indeed, it now is also in camel case and with 6 OK emojis here. Okay, so this one here is from the previous time. So each time we click the button, of course, this will get logged here. Okay, so that's it here. So make sure that you really understand how strings work in JavaScript, so you can review this lecture and the last 3 lectures. And if you want even more string exercises, you can let me know in the Q&A section, and I can then give them to you. Anyway, that's it for now. I see you in the next one. So over the last couple of videos, we have learned how to work with strings and also did a couple of exercises and one challenge. But many people have actually asked me to create even more string exercises. And so in this lecture, we're going to solve basically one more challenge and do one more nice string exercise. So somewhere at the beginning of your starter files, you will have this flights string like this. And so our goal is basically to transform this huge mess here, which is this string, into this nicely formatted output, which contains all the information that is in this string here, but then put it in a way that is actually legible to people. So let's pretend, for example, that we get this string here from some kind of web API, and our goal in our application is then to display the data like this. So let's start by taking a look at our string here so that we can think about how to approach this problem. So we see that we have basically 4 lines of output here, right? And so if we take a look at the string, we can see that we have here this first part, then we have this plus sign, and so you see that here's another one and another one, and so essentially this plus sign acts as a separator between these 4 pieces of information, so these 4 flights. So this one here I showed you is the first one, then here we have the second one, the third one, and the 4th one. Okay, so let's start by dividing that up so that we can transform this one string into these 4 pieces. And for now, I will simply log the result of doing that to the console, just so we can get a first look at this. So remember that for that, we are going to use the split method. So flights.split, and then we specify by which character we want to split the string. So give it a save, and then you see that we get this array, and this array contains now these 4 pieces of information, so these 4 flights. Now, again, you see here that we have actually 1 line for each of the flights. So that means that we want to log to the console 1 line for each flight. And so we should probably loop over this array and then create a string like this in each of the iterations. And so we also learned how to do that in this section, right? So we can use the for of loop. So let's say that each of them is a flight. And here we can then directly use flights.split, which creates the array that we just saw. And so again, to start, let's just log each of the flights here to the console in each iteration. And we can then get rid of this. Oh, and here we are trying to access that flight variable, but of course it is flights. So this string here. And so now indeed we get our 4 strings here logged separately to the console. And now it's time to actually build each of these nicely formatted string out of this mess that we get here. So again, we can notice that we have an element which basically splits or separates different pieces of the information inside of the string. So here we see we have a delayed departure, and here we have this airport code, here another one, and then here the time of arrival, which is exactly what we have in the string. So here we have delayed departure, the airport code for Faro, and then the airport code for Berlin. And so, therefore, let's extract that information from this string again. And so, again, I will start by splitting this variable, but this time using the semicolon separator. So exactly this. So you see it already worked. And now all we need to do is to get this data out of these arrays, then format each of these 4 pieces here a little bit, and then assemble each of them into the final string. So we can do this in many different ways, but what I'm going to do is to use destructuring to take these 4 pieces out of the array. So remember destructuring, we use the array syntax here, but to specify variables. So the first variable here, let's call it the type, because we can have departures and arrivals. So that's the type. The second one is the from. So you see here that the first airport code is the from, and the second is the to. So from FAO to TXL. So the third one is to, and then the last one is the time. So 1125, which we will then transform here into 11H25 like this. All right. So now, of course, we don't have the output anymore. But anyway, let's now start creating our output string here. So I'm going to call that output. And of course, we're going to use a template literal. And I will start by simply put these 4 variables that we just created in here. And so then we can format each of them individually. So that's type, from, to, and then the time. And we can already put that inside parentheses, just as we have it here. And then to finish, we will just log that nicely to the console. And so now indeed we have 4 strings right here. Okay, so let's now individually format each of these 4 pieces. And I'm going to start here with the time, which is the easiest one. So here we just want to replace the colon with an H. All right, that worked beautifully. And now let's go to the type. So you see that in the type, we always have these underscores, which of course we want to get rid of. So here it should just say delayed departure with a space instead of the underscore. And here in the arrival, we basically also want to get rid of the underscore. So essentially, we're just going to replace the underscore with an empty space. So here we can now actually use that ES2021 method that I mentioned before, but which didn't work back then. But now, as I'm recording this video, replace all actually already works in Google Chrome. And so here we can now use replace all. All right. So again, this is an ES2021 method, which is brand new in JavaScript and which allows us to replace all incidents of a certain string at once. And so again, we're going to replace the underscore with a space. Okay, that's nice. Now we see here that we have this empty space at the beginning of each string, but we're going to take care of that later because we will have to add some strings here, or actually some spaces anyway, in order to create this format here. So with this and all of these spaces here. All right, so don't worry about that for now. Instead, what we're going to do now is to add these red dots here. So these are actually emojis, and we will add this emoji whenever the departure or the arrival is delayed. So basically to symbol that there is a delay. So this applies to both departures and arrivals like this. All right, so basically we want to add this emoji whenever the type, so which is, remember, all of this, so this here, so whenever this starts with the string delayed, then we want to add this emoji here. So let's do that. And we actually have a nice and easy string method for that, which we already talked about, which is the start with. So starts with, and so here we're asking if the string starts with delayed, so actually like this, and remember that this is going to return a Boolean. And so this is perfect to then use a conditional like the ternary operator to return something in case this is true. So in case it is true, here we want to add this emoji. So we can just come here and copy it, paste it here, and if not, then simply add nothing. All right. Well, that didn't really work. All it did was to add like another space here, which is this one here. But I think I know what the problem is, which, and let me actually show this to you by logging here again the type. So we are looking if the string, so if the type string starts with delayed, but in fact, it does start with underscore delayed at this point, right? And so therefore, we need to add that here to our test as well. And then it works just like expected. Nice. So let's take away that log here, and let's actually take away that space. And so now we have a more evenly spaced text here. Great. And actually, we're almost done here. All we have to do is to now format these airport codes. Now, we have all of these numbers here and here as well, but they don't really serve any purpose here for formatting this string. So all we want is the 3 letters here, which any airport code is made of. So it's always just 3 letters, but the number afterwards, we don't care about it at all. So basically what we will do to this string and also this here is to take the first 3 letters and then convert them to uppercase. And then that's actually it. So let's do what I just said. So we use the slice method to take the first 3 elements. So from position 0 all the way to 3, where 3 is not included. So we're taking 0, 1, and 2. And then we can simply chain the to uppercase method onto that, and there we go. So that's fao now. And now we can copy the same thing from here to here. But let's actually not do that. But I will create a small refactor outside here. So basically create just a small function called getCode, which gets a string, and then from that string, it does this. So let's cut that. And that's it. So just a nice and simple arrow function just for this small use case. And notice how I defined this variable here outside of the loop, because otherwise this function here is going to be defined over and over again, which is not necessary. So now we can just wrap this into parentheses and pass it into getCode. And so that will then take this string, pass it into this function, which will then do the formatting that we wanted, and will return it. And let's do the same thing to the destination. And that's it. So we are almost done now. So a string is nicely formatted. It looks just, or at least almost, like these ones here. Now the only thing that's different is that here they are basically all aligned to the right like this, so that we have these airport codes here and the times all in the same position, which makes these strings a lot easier to read. And do you remember how we can do that? So for that we can use the padStart method that I also introduced some time ago. So we can do that on the entire string, which ends right here, right? So the output string starts here and ends here. And we now want to apply the padStart method on the entire string. So we can chain that right here. We could also put it here like this, but this formatting should actually be a part of the string itself. And so let's actually add it right here. So let's try 50 here. And remember that by default, the default character that will pad the string is an empty space. So if we give this a save now, then you see that indeed everything is now actually aligned here. But 50 is apparently a bit too much. Let's try 20, which is not really enough. Let's try 40 here maybe, or 30. This has to be a little bit like trial and error until it looks nice. But 36 it is. So now everything is nicely aligned, and all these strings are now exactly 36 characters long, which is exactly what this padStart does, right? So it makes sure that the string has exactly this length, and if it doesn't, then it keeps adding the string, or so the character that we define here. So we could also do like this, and then it would add this character here, but we simply want a space, so we can just get rid of that, and then automatically it adds this empty space. Okay, and that's actually it. That solves the problem that we set out to solve in the beginning, and on the way we practiced many of these methods that I showed you before, and we also used the ES2021 method here, replace all, for the first time. So I hope that you found this exercise useful and that you're now even more comfortable working with strings on your own.